In this video, we're going to do example 6.5.1, where we're asked to use row reduction to evaluate this determinant. So we're going to row reduce like we usually do and see where that leads us. And so normally we would take a 1 and put it up in the top left corner. So let's do that. That means we need to do an interchange. We'll do row 1 interchanged with row 2, and using our determinant row operation notation, we'll make that equal, but we have to put a negative sign in front, and so we can interchange those two rows and create a chain of equality of the determinants. So 2, 1, 2, 3, and then the other two rows stay the same. 3 minus 4, 11, 1, and minus 2, 3, minus 4, minus 3. Now what we would usually do is take this 1 and clear out the entries below it, make them 0, and so we're going to do that as well here. So creating our chain, we're going to do the operations row 2 minus 2, row 1, row 3, that's row 3 minus 3, row 1, and row 4 plus 2, row 1. So doing these operations, none of them change the determinant. Adding or subtracting a multiple of one row from another leaves the determinant unchanged, so we inherit the minus sign from before. We'll take row 1 and recopy it since it is not changing, and then we'll do these operations. So 2 minus 2, we get 0, 3 minus 6 and 3, 0, 2 minus 1 and 1, and 0, minus 1, 4, minus 3. Now we're going to hit pause here for a second and take a look at what we have. We've created a column of mostly zeros, which means if we do cofactor expansion down that column, well, we have one entry and then we have a smaller minor to do. So this is going to be our first method. We've done a little bit of row operations to simplify our calculation here. We're going to do cofactor expansion. So we'll stop here, and do cofactor expansion down the first column. And use cofactor expansion along column 1. So along column 1. So if we do that, we need our grid of plus and minuses. The top left is always plus. So plus, minus, those zeros, they really don't make any change for us. And so we're going to have the negative that's on the outside, and then we have 1 times the determinant of this 3 minus 6, 3, 2, minus 1, 1, and minus 1, 4, minus 3. Now, plus, minus 0, plus 0, minus 0, right? I'm not going to write those. We've got now a 3 by 3 instead of a 4 by 4. So this is very nice. We can use the first rule that we learned, Sarris's rule, to evaluate our 3 by 3 now. So 3, 2, minus 1, minus 6, minus 1, and 4. And so we end up by having the same minus 1 that's on the outside. And we do this product, which is going to give us 9 plus 6 plus 3, 4, 24, minus, and then the product's in the other direction, 3 and plus 12, and finally plus 36. So this ends up by giving us minus, and what do we have here, 15, 24, 39. 39 minus 15, 36, 51, and we subtract those two, so we get minus 12, or just 12. So just to recap, what we did there was use some row reduction to simplify. We had a 4 by 4 determinant to begin with, and that gave us a single entry times then the determinant of a 3 by 3. So we simplified the calculation by doing a little bit of row reduction first. So that's one possibility. The other possibility would be, well, not to stop, just to keep on going. So method 2 for this, and obviously you wouldn't do both of these methods. Method 2 would be to continue the row reduction from above. So continue the row reduction to REF, to an REF, to a row echelon form. So let's do that. So we're going to continue here, which means that we want to zero out down here, and this is a lovely feature there that I can divide by 3 very evenly. So we'll do 1/3 row 2, and we saw in a previous video that when you multiply by 1/3, that's like factoring out a 3. So I've got the minus from before, and then I have the 3. And so what is left is 1 minus 2, 4, 0, 0, 1, minus 2, 1 after that 3 comes out, and then 0, 2, minus 1, 1, and 0, minus 1, 4, minus 3. Perfect. So now we're going to continue as we would normally do. We'll use our leading entry and get zeros down below. So that means that we are going to do the following 2 operations. We will do row 3 minus 2 row 2 and row 4 plus row 2. So we're going to inherit this minus 3, and then we have the same first 2 rows, and then when we do our calculations, we will get, so 0, 0, 3, minus 1, and 0, 0, 2, and minus 2. All right, excellent. So continuing on down here now, what we would like is to use this entry and get this down here. So there's a bunch of ways that we could go about it. Why don't we take advantage of these? So avoid fractions. Why don't we take advantage of this row here, and we'll do 1/2 row 4, which is going to make us factor out a 2. So we've got minus 3 times 2 times, and then what we have is 1 minus 2, 4, 0, 0, 1, minus 2, 1, 0, 0, 3, minus 1, and 0, 0, 1, minus 1. Now, of course, the advantage of that was then we can use this 1 to come up here. We could have just subtracted. Now that I think about it, we could have just done row 3 minus row 4, but regardless, we've done what we've done now. And so we continue here. We'll do an interchange to get this into place. So that means we'll do row 3 interchanged with row 4. That gives me another minus. So that minus will cross off as I have minus minus. So we end up by 3 times 2 is 6. The minuses have canceled each other out from this interchange, and we have minus 2, 4, 0, 0, 1, minus 2, 1, 0, 0, 1, minus 1, and 0, 0, 3, minus 1. So one thing left to do then is going to be to take this leading entry and zero down what's below it. So one last operation then will be row 4 minus 3, row 3. That's going to leave me with the same 6 on the outside, and then 1 minus 2, 4, 0, 0, 1, minus 2, 1, 0, 0, 1, minus 1, and 0, 0, 0, 2. Because, of course, this operation, adding or subtracting a multiple, doesn't change the determinant. Now, we could factor out, or we could now stop and say, okay, we are in REF here, but more importantly, we are in a triangular form. We're in the upper triangular form, which means that the determinant of this matrix can be taken as the product of the elements on the diagonal. So that means we have 6 times 1 times 1 times 1 times 2, or 6 times 2 is 12. So that is the same value that we got above. I might argue that above was a little bit quicker than what we had done here, but both of these are well-known strategies for using row reduction to evaluate the determinant, and that's what this takeaway says. Takeaway: 2 common strategies for using row reduction to evaluate a determinant are, well, method 1 that we did was to apply row operations to make one column mostly 0. So mostly 0 to zero out most of it, and then apply another method like cofactor expansion or Sarris's rule to evaluate the determinant. The second method that we saw was actually to reduce to, well, we did REF, but in fact any triangular or a diagonal form would do and use the property that the determinant is the product of the entries along the main diagonal. So those are two strategies to make the determinant calculation a little bit quicker by first doing a little preamble with row reduction. In the next video, we'll see an example where we have a determinant with a known value that we have to use row reduction to evaluate another crazy looking determinant in terms of the first one. See you in just a moment.